is a resident medicine. Today, the topic of our lecture is data science in medical research utilizing R and Python for descriptive statistics. You have heard about R and Python, but now the lecture is how to use it in descriptive statistics. First, the learning objective of this session will be 5 points. Understand the fundamental concepts of descriptive statistics. Identify key measures such as mean, median, standard deviation, and variance. Interpret frequency tables and proportions. Recognize the importance of visualization techniques and data analysis. Compare the implementation of descriptive statistics in R and Python. These are our objectives, which will show us how to use R and Python in descriptive statistics. Now, the introduction to data science in medical research is data science is in medical research. In this session, we will explore how data science, particularly through the use of R and Python, is transforming medical research. Our focus will be on descriptive statistics in this session. We will later on focus on inferential statistics and other data analysis, which will be done on Python and R, fundamental aspects of data analysis that provide valuable insights into medical data. Now, overview of data science in medical research. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. Like we use different type of data, which the data science use for us in R and Python and give us the exact thing which we want. Relevance to medical research enhances decision making in patient care, facilitates the discovery of new treatments, improve the efficiency of clinical trials, allow for better understanding of patient population tool use. Now, what is R? R is a programming language and software environment for statistical computing. R is only built for statistical methods, but the Python is a versatile programming language with rich libraries for data analysis. It means that R is a statistical language and Python can be used for various purposes which have rich libraries and can be used for data analysis. Now, why do we use descriptive statistics? Descriptive statistics summarizes and organizes characteristics of a data set, like we have talked about earlier, that mean, standard deviation, variance, and other plots, and these are created by in descriptive statistics. Provide a simple way to visualize and understand the distribution and patterns within the data. Now, importance of descriptive statistics. What are the key functions of descriptive statistics? The key functions are measures of central tendency like mean, median, and mode, measures of variability like range, variance, and standard deviation, and frequency distribution. These are the key functions in descriptive statistics. Now, key concepts in descriptive statistics are mean, which is the average of a data set, median, which is the middle value, mode, which is the most frequent value occurring in a data. Standard deviation indicates how much individual data points deviates from the mean. Range, the difference between the highest and the lowest value. Visual presentation like histogram, box plot. These can be made by the data analysis tools like R and Python. Now, introduction to R and Python for data analysis. Both R and Python are powerful tools for data analysis, each with unique strengths. Like R is an excellent tool for statistical analysis and visualization. R can only be used for statistical analysis, and Python is a versatile language for general programming and data analysis. There are many libraries in both the languages like R have ggplot, dplyr, and other libraries, and Python have pandas, NumPy, and the other libraries. Choosing between R and Python depend on specific needs of the analysis and researcher familiarity. If a researcher know about R, then he will use R for the data analysis, and if a researcher know about Python, then he will use the Python. Now, R in a descriptive statistics. How R is used in descriptive statistics? The basic summary is R has several functions that allow us to calculate basic descriptive statistics. The mean provides the average of the data set. Median represents the middle value. The standard deviation and variance measures data dispersion. The range shows the difference between the smallest and largest values. Quantiles divide the dataset into equal parts. Now these are the basic codes which is used in R. As we are talking about R, so in R, for mean, the main code is mean, and in the bracket that is the data which we use. Data, the name of the data can be different, which we can name like median end data, standard deviation, this SDN data. For variance, VAR data, range or quartile, and statistical summary for summary and data. Now this is the first picture in which we will calculate mean, median, standard deviation, variance, range, quantile. As you can see, X is the data. X is the data. If you have gone through the Public Health Academy of Saudi, you have learned about the data frames, data types. So the X is a data type which can be named as list, and this list we can use that which is the mean in this list. So if we apply the code mean and in the bracket X is the data, so the mean is 45.5. Similarly, for median, standard deviation, variance, range, quantile, you can also use these codes for different data. Now this is the full picture, which you can see that X is the data and mean can be calculated by the code, which is mean and bracket में data. Similarly, median X SDX where X which is the variance 982.6364, range 2 and 98, quantile. Now frequency tables to analyze categorical variables. R provides a way to create frequency tables. These tables help in understanding the distribution of categorical data by counting occurrence of each category. To create a frequency table in R, the code used is table and bracket data. And similarly for the proportional table, we can use the lower code. Now this is the codes in R for frequency and proportional. You can see on the lower.
Dr. Nasrullah, sorry to jump in the middle. Can you just explain what are these different windows and everything? Like for a student who has never gone through anything. So just if you can go through this. I know some of them have gone through the Saudi Public Health Library, but none of them will be working at your level. So just as easy as possible, just explain when they open R, what do they see? Something like that.
Okay, sir. When we open the R, when we install the R and then open the R Studio, there are four windows on the top left, top right, bottom left, and bottom right. The top left is the area where we edit our code. Like there is no running of code, but only we edit our code so that we can get the best possible code for our uh, R analysis. Then the left bottom is the analysis area where we run the code. This area is for running the code. Like you can see on the left top, there is no running of code. Only I have entered the codes. But in the left bottom, the codes are running and then the analysis is done like data, then table, and then the results are coming like data 23, 24, and similarly for proportional table. Then on the right top, this is the environment. It can give you can see 4 options in an environment: history, connections, tutorial. So if we forgot a code, then we can retract it from the history. The environment give us the variables which we have made in the code, and the lure is the area where we will see the plots as coming in the next slides. Now this is the frequency table and proportional table. You can see the code running, and then the results is in black. The code is in blue color and the results are always in black color. So you can see the results as data 23, 35, and so on. And for proportional, the data is 23, 34, and so on. Now visualization in R. How will we visualize the data in R? Data visualization aids in interpreting patterns within patient datasets. It helps researchers identify trends, detect anomalies, and communicate findings effectively. Various visualization techniques are used to represent numerical and categorical data graphically, making complex medical datasets easier to understand. Histogram help in assessing the distribution of continuous variables like age and blood pressure, while box plots are useful for detecting outliers in patient health indicators. Scatter plot can illustrate relationship between different health parameters, aiding in correlation studies and predictive modeling. Now these are the visualization codes. As you can see, we can visualize scatter plot, pie chart, histogram, box plot with these codes. For the scatter chart, the code is plot and data. For pie chart, it is pie and data. For histogram, it is histogram and data. For box plot and data. We can also add colors, weight, and legends to the top, whichever area we like in the plot. Now this is a scatter plot for the data we have used earlier. The data you can see in the left bottom here. The data is data and in blue color. Then on the right side you can see the scatter plot. As I entered the code plot and data, it have given me the plot. Now here I have added a color and not color, weight, that it can show. Here you can see the weight is small and here it is filled and showing. Now this is again the plot data. Now here I have changed the color. You can see in the data here, you can see to the arrow side where I have added color green. So the scatter plot have given us points in green color. Now this is a pie chart. As we have discussed about the pie code, the data is used for pie, and then the pie and data code have given us the visualization. So here you can see we have also add grass on the top. It means that the name of this plot is grass. Now here we have added some colors to the pie chart. We can also colors areas of the pie chart, like you can see on the left bottom colors. I have first I have created the color variable, then I have entered the color in the pie code. Now here you can see the histogram. Similar like the pie chart, we can use the histogram here. You can see the data is data 1, and then the histogram is created by the code hist and data 1. Here I have changed the colors for the histogram. Then I have then add the color variable. If we use the colors, we can visualize it more greatly. Now here is again the histogram plot with changing colors. Now this is the box plot. In the box plot, we have entered the data, like you can see the data here. Data in blue color, C34, 26, 67. And then we have entered the code which can give us the plot. This is again the box plot, but here we have added age, patient, and box plot of the patient. It mean that we have added the name of the plot and x and y horizontally and vertically. Which variables are we seeing? Like here you can see in the last code box plot, first of all there is a data, then there is name of the plot, like box plot of patient ages. You can see it in on the top of the plot. Then x lab patient, it means that the horizontally we will assessing the patient, and y lab we will assessing vertically age. Now here you can see the change of color in the box plot. Like here it is gray color, and then here is it is green. Like here you can see in the last code it is called col is equal to green, then it will give us green color. Now descriptive statistics in R, Python.
Just,
We have
sorry, Dr. Nasilo, just stopping in the middle. So, dear students, all the codes for all of this has been given in a Word document in the Google Drive. You can look in the Google Drive. Dr. Nasrullah has created a Word document which you can use, and you can use these codes and then directly apply. The whole presentation has been made available to you guys again in the Google Drive. Furthermore, the session that Dr. Nasrullah is conducting right now, this video will be made available also in the Google Drive. So even afterwards, if you want to practice, you can look up this video. You can see what he's showing over here. For this presentation, we are using dummy data. What dummy data means is that basically Dr. Nasrullah creates a data and then he applies descriptive statistics and visualization techniques on that data, which is basically, if you see at the very top, the variable D, and then the data is being shown in there in the parentheses. So I'll just stop here. Just wanted to do this and also just want students to, if you have any question regarding R before we move into descriptive statistics using Python. If you have any question, please let us know. If there are no questions, then Dr. Nasrullah will move into R, Python.
Doctor, I just wanted to know which one is better, R or Python for descriptive.
Both are equal, both are better. There is no, so think of it like this. I can learn science in Arabic. I can learn science in Chinese. Which language is better?
I would say Arabic, for me at least.
See, so no
Uh,
language is good or bad, right? All
yes, yes, of
languages are
course,
equal.
yes, yes.
Same thing. These are programming languages, right? Language, right? So some might have a different syntax, means different grammar, or a different vocabulary, means different use of words. So different syntax and different vocabulary might exist, but R is a very powerful programming language. R has multiple packages. In subsequent lectures, Dr. Nasirullah will take us through different packages. He is an expert of R, mashallah, and now he's also becoming an expert of Python. So both of these things, both of these languages are equally great. Okay, so I'll just stop here, Dr. Nasirullah. Sorry, I'm jumping in the middle, but because these are my students, I know that these are the questions that they keep on asking me. So therefore, I came in the middle. Thank you. Please carry on.
If you don't have another question, can we move forward? Okay, now we will be studying Python, descriptive statistics in Python. Descriptive statistics in Python provides essential insights into medical data sets by summarizing key characteristics such as central tendency, variability, and distribution, as we have studied in R. Now, Python's powerful libraries, including NumPy, Pandas, and SciPy, allow researchers to efficiently analyze patient data, detect patterns, and identify anomalies. These statistics helps in understanding the overall structure of clinical datasets before applying inferential methods. By utilizing Python's visualization tool like Matplotlib and Seaborn, researchers can present findings in an intuitive and interpretable manner, aiding in effective medical decision making. Now these are the two libraries which are used for descriptive statistics, NumPy and Pandas. Python provides libraries such as NumPy and Pandas for statistical analysis. The mean, median, standard deviation, variance, and range, as we have discussed in R, can be computed easily using these libraries. The describe function in Pandas offers a summary of key statistical measures for a dataset. Now you can see the codes in Python. It is a bit different from the R, as in R it is only mean and data, but in Python it is a versatile language, so we use a specific library for it. But mean that NP means NumPy library. We are used NumPy library for the descriptive statistics here, like np.mean and then the data. The codes are similar to R, but the difference is that we add the library name to it, through which we will be doing descriptive stats. Now this is the ideally shell which is used for Python. On the top, first of all we have to import the library both in R and Python. Like you can see here, I have import numpy as np. Then we can do the descriptive analysis. If we didn't import the libraries in R and Python, we can't do the analysis. So first of all, import the libraries. But before the libraries, you have to install the libraries. First of all, we will install the libraries, then import the libraries, and then we will do the analysis. So the data, I have put it the data that the data is 2334, similar to the R. Then I have added the code for mean. That mean is equal to okay, in R and Python there is a bit difference in syntax. Like in R we use mean and then there is a lesser sign and a dash, and then we create a variable with it. But here in Python we will use is equal to create a variable. Like mean is equal to, then we have applied the code np.mean and data. And here we will use print for the data and analysis which have to be shown. But in R we don't use print. There we use view or summary. Similarly for the median, you can see median is equal to and then np median and data, then print. So all the data are given here, like standard deviation, std. In the R there is st, and in the Python there is std. So for the variance, it is similar to R, var, but before that we have to add the library np dot. Now in frequency tables to analyze categorical data, Python provides method to count occurrences and calculate proportionals. To create a frequency table in Python, occurrence of each category, counter and data. So here is the data. You can see the whole screen, and then I have cut it the main area where we are working. like frequency table is equal to counter data. This is the code for frequency tables which we want to use, like counter and in the bracket data. Okay. Now visualization in R. Importance of data visualization. Data visualization is essential for exploring patterns, identifying trends, and understanding the distribution of data, making complex data sets more interpretable. As discussed in R, histogram for distribution analysis. Histograms are useful for visualizing the frequency distribution on numerical data by dividing values into bins, helping to detect skewness, outliers, and normality. Box plot for summary statistics. Box plot provide a visual summary of numerical data, displaying the mean quartile, median quartile, and potential outliers, making them valuable for comparing multiple data sets and detecting variability. Now these are the codes in Python for visualization. Like you have seen in the R, it is only using hist and data, but here we will use the libraries like PLT and SNS. The histogram PLT dot hist and data. In boxplot we use SNS library, Seaborn library, and in pie chart again we use PLT library. Now here you can see the box plot which is being made. First of all, we have imported the two libraries, matplotlib as PLT, so we can shrink the name like PLT, and cburn as SNS. It is for the easiness. So here the data is given, SNS box plot data is equal to data. The code is for box plot is we have to enter two or three things like the data and colors. So the data is data which is the variable, and color is blue, red, green, whichever you want. Then PLT table will give us the plot. Like first of all we have to enter a command that this is our data and we want the color in this type. Then we will use the PLT library which will analyze the code. Then X label, we have added the X label is distribution, and then plt.show. It will show us the plot. If we didn't enter the plt.show code, the plot will never appear. Like here you can see the four arrows. The first is for SNS, your cburn library. The second is then PLT table, which will make the table. And then the third is for X label, as you can see in the plot in the lower right, data distribution. You can also add these names to the tables. And then for showing the plot, you will always uh, enter the code plt.show for showing the plots. Now this is a histogram. In histogram, you can see the code with three arrows like C1 library and PLT. Here again, these two libraries are used, sns.histplot and data1. Here the code is a little bit different, and PLT histogram and then PLT.show. And this is a pie chart which we can see here on the left bottom that the codes are in four arrows. The first is data, the second is analyzing the data, the third code plt.title, which title we want to give to this pie chart. So I have given pie chart, and the fourth plt.show, it has shown us the visualization. The conclusion is descriptive statistics provide insights into dataset before further analysis. R and Python offer powerful tools, built-in functions and libraries for statistical computation and visualization. We can use statistics like descriptive statistics, inferential statistics, and visualization through these languages R and Python. Proper data visualization help in understanding distribution and trends. A strong foundation in descriptive statistics is essential for data analysis and decision making. So this was the presentation for R in Python descriptive statistics plus visualization in the descriptive statistics. Thank you.
Thank you so much, Dr. Nasirullah. This is great. This is great presentation. Thank you so much. I'm just